Right now, the E3 specification, otherwise officially known as SFF-TA-1008, is in the middle of a reboot, or at least it is when I'm recording this. By the time you're seeing this, it may be an approved specification. One of the major capabilities that we're doing is to make it more compatible with the OCP NIC, so the slots can be used for both types of devices. Also, we're changing it so that you can design E1.S hardware that will fit into the E3 slot carriers. So the major specs involved for E1.S form factor are the SFF-TA-1006. That gets you the small candy bar shape. You have the E1.L, which is SFF-TA-1007. That's the long one, sometimes called used to be called the ruler when it was first introduced. And then we have the E3 specs, which are both under SFF-TA-1008. All three of these specs share the SFF-TA-1009 PCIe mapping.
Whereas E1 kind of limits out at by 8 interface, as well as some lower power profiles, that the E3 really allows you to go to a much larger power profile. So they'll take care of some of these application use cases that we see in the enterprise market, things like storage class memory and future CXL devices that are going to be more power hungry. Going to PCIe Gen 5 power requirements drive up to that 35+ watt range. And so those where we see accelerators for computational storage, and also PCIe Gen 5 and beyond enabled with the E3 form factor. You just have more surface area, more ability to support larger ASICs inside the device to support multiple device types.
Okay. Then we have the E3.L, which is the single width. These are 7.5 millimeter devices. And then we have the E3L2T, which is the double thickness at 15 millimeters. So the E3.L2T is roughly the same size as a current 3.5-inch drive, if you want to think about it that way. And as you step up in size and capability, like you can see off to the right there, you can support, by 4, by 8, or by 16 connections. That's all defined by SFF-TA-1002, which is the connector definition. And you can support various power profiles. The E3 short, or E3.S, is in the 20 to 25 watt range. The E3, the double thickness, we're looking at 35 to 40 watts in there. The E3L, we're looking at 40 watts. And the E3L2T, the double thick, 70 to 80 watts, somewhere in that range. And we may actually be able to go to higher power profiles than that, because we're looking at creating a new variant of the TA-1002 connector that has an additional power tab.
And density that you need.
Well, it sounds like it gives a lot of flexibility and opens up new types of architectures. Maybe touch on a little bit more some of the design advantages.
The OCP pins, which are, I can't point to anything, sorry. It lines up with the OCP
Oh yeah, I mean, like I said, this allows us to do front-facing I/O, so we can take essentially a NIC and plug it into one of these slots and bring I/O out the front. By moving the connector, we aligned ourselves with the OCP3 NIC, and it turns out that the OCP3 NIC uses the SFF-TA-1002 connector, so we were able to align there. And it's a really good illustration of multiple standards groups working together to a common cause.